Hi viewers, you're welcome once again to MOG Economics. So in our last class, we treated the concept of Maclaurin. I introduced the concept of Maclaurin and Taylor series, and then we started with Maclaurin series. So in the last class, I told us that in the next class we're going to look at more complex solutions, more complex questions. So this is one of those questions that may be asked to solve. So in this question, the question says, find the first three terms in the Maclaurin series for x over into root 1 minus x squared. Alright, so for this question, we are either going to use the quotient rule, or the product rule. Yeah, it now depends on whichever method you want to, but for the sake of this class, we are going to be using the product rule. So now, the question says, this is the question: f into x, f of x, x over to the square root of 1 minus x squared. Now this can be written as this. So this is the product of two entities. And now, what do we mean by the three terms? The question says we have to find the first three terms in the Maclaurin series. Now, from the formula, the Maclaurin formula that we derived in the last class, we have something like this. So now, for the case of three terms, that means we're going to be having something like this. The first one, which represents the original function, and then the first derivative. The first derivative, and then the second one, so here we have three terms. This for the original one, then for the first order derivative value, and this is for the second. So what we are going to do now is to take the first order differentiation of this and then the second order differentiation, so we can substitute the result of what we have into this formula. So we'll start by taking the first order differentiation of this. So the first order differentiation of this will be, so applying the product rule. Now, for the product rule, we are separating these two terms. Let this be u in this case, and this be v. Going back to our law of differentiation, when we have two entities that are separated by a product in this case. So here for x, let's have a rough work somewhere. Let's say we have our x to be u, and the other entity here to be v. Now the differential of u is du dx equals, this is 1, and then for this u dv equals this. So
dv dx.
Sorry, dv dx. So we differentiate the entity within the bracket, and then we also differentiate the entire function itself. So let's start first of all by differentiating what we have within the bracket. So differentiate what we have within the bracket, we then multiply, we take the result of that and multiply with the differential of the original entity itself. So here we have minus 2x, yes, and then if we differentiate this original entity, we have then here we take the one from this. here the term here cancels this, the 2 here cancels this 2, and then minus, multiply by minus, then we have here we have x, 1 minus x. Now here minus, this is, sorry, this is minus 1 over 2 minus 1, which is minus 3 over 2. All right. So the formula for our product rule is u dv dx plus v du dx. So in this case, the product of this and this, our u from here is x, and our dv dx is this. So that will be x squared 1 minus x minus raised to the power of minus 3 over 2, and plus the product of v, then now the product of v and the u ds. So this is 1 in this case. So 1 multiplied by this, the result will be 1 minus x squared raised to the power of minus 1 over 2. So that is our first order differentiation. X squared minus 1 over 2. Alright, let's put this kind of. We are done with this. Alright, let's do the same for the second order differential. So what we are doing basically here is to differentiate what we have as a result of our first order differentiation, to differentiate again. So to do that, so now here again we're going to apply the same differentiation again, because this is second order differentiation. So we are going to apply differentiation again on this first. We are going to apply differentiation again to this first differentiation, our result for the first differentiation. So we apply differentiation again to get second order differentiation. Now the first time on the right hand side here, we are going to apply the product rule again. So here, the first time here, okay, x squared 1 minus x squared to the power of minus 3 over 2. So the first time here represents with u, and then the second represents with v. Right. So this, the u ds from here is 2s, and the v ds from here is, okay, now we apply the power function here. The term within the bracket is minus 2s, and then we differentiate the whole entity. Here we have this, then we go on from here, we have minus 5 over 2. Alright, so this can be simplified further. Then we have, okay, this cancels this out, minus multiply minus, then we have 3s bracket 1 minus x squared, then raised to the power of 5 over 2. Then the formula for our product rule again, u dv dx plus v du dx. Then u from here is x squared, and dot dv dx from here is 3x 1 minus x squared 5 over 2 plus v from here is this 1 minus x squared raised to the power of minus 3 over 2, and then our du dx from here is 2x. So then our final result from here is this multiplied by this is 3x cubed open bracket 1 minus x squared raised to the power of minus 5 over 2 and plus here and bring this to the front, and then we have raised to the power of minus 3 over 2. Alright, so from here, this is the result of this, the first expression here. Let's see if something we can do to this. Okay, let's just write that down first. 3x cubed 1 minus x squared raised to the power of minus 5 over 2 plus 2x 1 minus x squared raised to the power of minus 3 over 2. Then this other part, we apply the power function rule. So we have 1 minus x squared raised to the power of 1 minus 1 over 2. Alright, so the entity within the bracket, we differentiate that first, and that's minus 2x. Then the whole entity itself, we differentiate that. So that's bringing this forward, x squared. Then from the power, we take away 1. So this can be reduced. Then we have minus multiplies minus. We have this 1 minus x squared. Then this is minus 3 over 2. So that's the result. And then, so this becomes plus. So the result of this is this x squared raised to the power of minus 3 over 2. Alright, so we have our first two derivatives. Then, so if we insert the value of 0 in this, what do we have? So by inserting the value of 0 into these individual derivatives, we have, for this first one, this disappears because once we have 0 here, this first time multiplies it, so the whole of this is 0. Then if we insert 0 here, this expression here reduces to 1. So that's like saying, okay, let's have f prime open brackets, f prime open bracket 0, that equals, this is 0, so here we have 1 as the result. Since this one is out of the equation, then this reduces to 1, so 1 is the result. Then for the second order derivative, so by imputing 0 again, here this is out. Again for this is out as well. This is out as well. So this is 0. Now, don't forget this. The original function itself is 0, because this is the original function. So if we put 0 as the value of x here, this becomes 0 over into the root of 1 minus 0. So that's 0. So therefore, by applying the formula now, I have this to be 0. This is 1. Then this plus this is 0. Don't forget just have something like this. So okay, here this is x, then this reduces to 0 plus 0, and then our result is, that's the final answer. I don't know if you have any question, you can drop them in the comment section. And so at this point, this will be the assignment. And as students of emoji economics, I'm sure you know where to drop the assignment. So now the question says find the first three terms in the Maclaurin series for the following. First one is 1 all over 1 minus x squared, and the b part is 1 over into the square root of 1 minus x. Thank you very much, and see you in the next class.